This is our presentation for FSE 100 Intro to Engineering. This is for our lawn care robot swarm. We are team number 3. I am Chris Tooley, a mechanical engineering major, and with me are the rest of the members of my group.
Jason White, I'm a mechanical engineering major also.
I'm Zach Strange, studying software engineering.
And I'm Tyler Kurzbach. I'm an electrical engineering major.
So to discuss our opportunity, according to the United States Consumer Product Safety Commission, 230,000 people are injured by lawn care garden tools each year. This is due to overexertion, heat stress, chemical exposure, as well as several different types of mechanical injuries. Some additional concerns or benefits that we have with our project is that our lawn care is a time-consuming task. So we're looking to improve the work-life balance for our customers. And we're also looking to increase manufacturing and technician jobs, a shift from manual lawn care jobs to in the field to manufacturing jobs in a factory setting with increased benefits there. And then there will be an increased need for robot maintenance technicians and repair jobs. Our customers are working households, elderly, disabled individuals, and businesses with lawn care needs. The proposal is to have an automated system that will remove debris, cut and edge a lawn, remove grass, clippings and leaves, irrigate and fertilize, and improve overall lawn health. This will be done with minimal personal intervention, resulting in a reduction of yearly injuries. We have 4 robots to accomplish our task: a debris bot called the Claw, a grass cutting bot, a leak collection bot called the Aardbart, and a watering and fertilizing bot.
Cool. So for the first robot is the debris collection robot, the Claw, which was designed by me. It's a 4-wheeled, pretty much mobile crane-style robot with a large tethered claw on the end of it that uses to pick up debris that it finds using the forward-facing sensors, lifts those up, drops into a collection bin in the back, and once it's full, it returns to base and unloads its collected materials.
This robot is a grass cutting robot, in which we have a main blade underneath the robot and a side blade out to the side. The robot will navigate the yard using 2 distance sensors, as well as an IR sensor to detect when the distance sensors detect that it's up against a fence or object. The edging blade will become active so that while it cuts the grass, it will also edge the yard.
Then we have a leaf and clipping collection robot. This robot works kind of like a large vacuum. It has a nozzle on the front that moves side to side and up and down to stay a certain distance off the ground. It will collect debris into large bags, which it will then drop on the ground once they reach a certain weight. It will send a signal to the debris collection bot to come and pick up those bags as it continues its work.
This is the water and fertilizing robot designed by me. It has 2 moisture sensors. One is positioned 1 inch into the soil, where the other bottom sensor is positioned 6 inches below the soil. It also contains a reservoir to hold fertilizer. It will continue to water the grass and also supply fertilization. And once the bottom sensor detects moisture, the lawn is well saturated.
This is a demonstration of how our robot system functions. There will be a main control unit that the user will use to set up the area by walking around it while recording their GPS location. This GPS location will be used to guide the robots during their work. In the standard operation mode, which is a fully automated operation, a signal will be sent out to the first bot, which is the debris collection bot. It will then activate and begin driving around the lawn using GPS to guide it. And as it finds large pieces of debris, it will pick them up and place them in its rear reservoir. And it will continue around, picking up all of the debris in the lawn. When it's done, it will return to its home base location and send a signal to the mowing bot, which will then go out and mow the grass. When the mowing bot runs into an object such as this nice trident here in the middle of the field, it will move around it while activating the side blade to edge around it and make a nice clean cut. Again, once it's completed its work, it will return to home base and send out a signal to the next bot. The next bot goes out and begins vacuuming up all the grass clippings left by the mowing bot, and eventually it will have filled an entire bag, at which point it will drop the bag on the ground and carry on with its work. It will also send a signal to the debris collection bot, which will go out and collect that bag, removing it from the lawn, and it will return to its spot. Once the grass clippings bot is complete, it will return to home base and send out a signal that its work is complete. The water and fertilizing bot runs semi-independently of these bots in that it does not work in the normal cycle with the bots. It takes measurements continuously and will water the grass when it is needed, but only if the other 3 bots are not working. So if it has received signal that the other 3 bots are finished and it sees that it needs to water the grass, it will do so.
Benchmarking. Why choose our solution? To the right are the competitors that would also provide lawn care servicing, but usually they're often super pricey and they only solely focus on one aspect of lawn care, whereas the swarm of robots that we provide will complete several different tasks, such as leaf collecting, watering, debris collecting, and grass cutting.
All right, and in conclusion, so our solution uses automation to fully remove an individual from a potentially hazardous task, which was lawn care and gardening. So we propose to generate alternative jobs to offset this, such as the technical maintenance on the machines and installation of the watering system for these machines and setup. And then our group collaboration was instrumental through us overcoming design challenges. We got together every 2 times per week, and we made sure that our designs were pretty much flawless. So uh, this project, Group 3, is probably going to be the best one you see.
That was our presentation for FSE 100 Intro to Engineering. Thank you for watching.